Hello guys, this is Wits Lounge, Learning Made Easy, and today we are going to be studying an important concept known as stoichiometry, otherwise known as mole concept. Now, this particular study is going to be shared into different talking points which will be found in different videos, so do like and subscribe to get notified as the videos pop up. Thank you very much. Now, let's get into the talking points for this study. First of all, we'll have to describe or define the concept of stoichiometry. Then we discuss and understand the quantities of measurement in chemistry. After that, we look at the relationship between these quantities and finally talk about stoichiometry of reaction. So, what is stoichiometry? To the layman, stoichiometry is the branch of chemistry that deals with amount. Once you think about the chemistry of amount, you just talk about stoichiometry. This definition, however, is not all-encompassing. So let's look at a more broad definition of stoichiometry. Stoichiometry is the branch of chemistry that deals with the application of two laws, the law of conservation of matter and the law of definite proportion. So the question is, what is the law of conservation of matter and what is the law of definite proportion? The law of conservation of matter states that matter can neither be created nor destroyed, but is converted from one form to another. The implication is, anytime you consider matter, it remains the same. The only thing is that it changes form. But you can never destroy matter. Neither can you create it. Now note, this concept only applies to normal chemical reactions and not to nuclear reactions. So, let's look at things that could help us understand this. Imagine you have a reaction between silver, Ag, and chlorine to give you silver chloride. Let's more or less balance this equation. Sorry, this should be 2 here. Yeah, chlorine is a gas, so it exists as a diatomic molecule. Okay, so let's say you have this reaction and you have 54 grams of silver reacting with an unknown mass of chlorine to give you 89 grams of AgCl. Now, if you happen to be asked what is the mass of chlorine, based on your understanding of the law of conservation of matter, the total masses on the reactant side should be equal to the total masses on the product side. Hence, what do we have? 54 gram plus X equals 89 gram. What does that leave us? X is going to be equals 89 minus 54. Hence, X is equals about 35 grams. So you have that. The mass of chlorine in this reaction should be 35 based on the law of conservation of matter. So the point is this: the total mass on the reactant side equals the total mass on the product side. With that explained, we go to the next concept, which is the concept of definite proportion. Now, the law of definite proportion simply states that all pure samples of a particular chemical compound contain the same amount or the same number of elements which are combined in the same simple proportion by mass. It kind of sounds ambiguous, so let's simplify it to make you understand it. Now, what this law is simply trying to say is that if, for instance, you have water in your house, I presume you do, and the water in my house, provided they are both pure, they will contain exactly the same thing. Let's look at the board to understand this. If you have water is H2O, which means that it contains the same elements, hydrogen and oxygen. But that's not just that. The law also says that they must be combined in the same proportion, and we notice that the proportion of combination is 2:1. So if you have water in your house, it contains hydrogen and oxygen, and the proportion is 2:1. If I have water in my house, it contains hydrogen and oxygen, and it's 2:1. So anywhere we have water, they must contain the same elements, which are hydrogen and oxygen, in the same proportion, which is 2:1. With that said, I presume you have understood this. Now note, if you have the same elements but different proportion, like H2O2, that's not water. They have to be the same number of elements combined in the same simple proportion.